Hello and welcome to Aerospace and Mechanical Lab 1. Today we are going to talk about the third lab in the Lab 1 series. The third lab is going to focus on 3D scanning and 3D printing, which essentially means that we have the lab itself has two parts. Before starting the lab, you want to keep in mind that this might be a time-consuming process. I wouldn't call it a difficult process, just time-consuming. The 3D scanning part might get a little bit annoying. So what we have done here is we want to divide you each group into two different groups, and a couple of you, two of you will work on 3D scanning to create a CAD model, and then a couple of you will be given a pre-built CAD model of a simple cube to 3D print. And then each group of the lab, we have three 3D printers in the lab. Each group of the lab will do one different infill densities. I will talk about what an infill density is later on, but we are going to start with the 3D scanning. So the 3D scanners that we have are the Creality Raptor Pro 3D scanners, very simple. They actually connect to a computer. Of course, we need a computer connection to make sure we actually build our CAD model, and they come with a power connection too. So to start the 3D printing process, you need to calibrate your 3D scanner. The 3D scanners, the calibrations look like this. The orientation of the calibration panel is important. Look at these 4 dots. This is how you will determine the orientation. On the computer, it will show you how to actually place the calibration panel and how to calibrate it step by step. So we are going to actually see a screen recording, a laptop recording of the calibration process shortly. And on the back of it, there is a scanner. There is a QR code which you have to scan with your 3D printer to make sure the correct calibration mechanism pops up. After we're done with the calibration, we're going to use this pre-printed cube that has markers, 3D scanner markers on it. These markers are very important. And also this panel that will act as your surface. So we're gonna put the cube like this, and then we are going to 3D scan it from each side. We build a CAD model of the top of the cube. Then we do it again for the bottom of the cube, and then fuse the two CAD models to build one cube. Your job would be to compare the volume or the surface area of this cube to the one you have built. Right? That is one of the things that you need to do for the worksheet. You need to find an error. And of course, you share with data with your teammates and your classmates. Sharing the data isn't an issue. You just have to work on the worksheet yourself. So let's begin the process. We are going to have the 3D scanners in the background, and we are going to see what needs to be done on the screen. The scanner will be in the background. Whatever you need to do on the scanner, I will bring the scanner in front of the camera and show you what to do. Okay, so we are ready to start the 3D scanning process. The software we use here is the Creality Scan. This is software that comes with the scanner. Okay, it will take a little bit of time for the scanner to actually pop up, to be ready for us. So this is the environment. The first thing you want to do is to calibrate the scanner. It is asking us to scan the QR code on the back of the calibration panel that I just showed you a little bit ago. So you want to press this button that will start the camera, and you click scan the QR code, it will start scanning, and it did recognize the QR code. It is just giving you a direction. So this is essentially where the top of the camera should be. You want to make sure that this dot aligns with the top of the camera. I just have to rotate this, and we can start the calibration. So calibration, as you can see, we have this yellow scanner, thing that looks like a scanner, and this is a top view. This is where we should hold the scanner. As you bring the scanner close to the calibration panel, you can see it tells you where the scanner is. And then you just want to make sure you actually align the actual scanner with the yellow shape. This calibration process only has, I guess, 2 tricks. One is you want to make sure you are at the correct location, and you want to make sure you are at the correct orientation. At all time, you have to make sure your cameras are looking at the big dots. I think this should be the last step of the calibration. Okay, the calibration is going through. It takes a little bit of time for the calibration to be done. But when it is done, we are going to be ready for the actual CAD model scanning. You want to make sure you actually put the calibration panel back where it is supposed to be, where the calibration panels come with the 3D scanners and need to remain with the 3D scanners. Okay, calibration is done. Next stop is to do a new project. When you click on the new project, it will ask you for a name. I'm going to name this test. And it is asking me for a location. I'm going to save this in my documents folder. Okay, hit OK, and there we go. So on the left here, we are given a couple of different options. Of course, we have a scanner that uses a blue laser, so we don't really need to change anything there. And there are 2 options here, point cloud and global marker. The first thing you want to do is to actually identify the global markers. The global markers are these dots right here. I'm going to put this right here. I'm going to put my cube on top of it. One thing you want to make sure you do is not to change the orientation. You want to keep this orientation as consistent as possible for the time when we are creating CAD model of the bottom of the cube, which is essentially pretty simple. We take the CAD model, we create a CAD model from all of these sides except for the bottom, and then we create a CAD model for all of these sides except for the top. We fuse the 2 CAD models. Okay, so let's begin. We want to do the global markers first, and then we want to hit scan. Of course, we want to preview. We want to have a preview to make sure we actually are doing the correct scanning. So you want to be at an optimal position. You can see all of these are identifying the markers. If I go too close, the markers are going to become red. If I'm too far, the markers are going to become dark blue. The yellow, the green is going to be our targets. Okay. You want to make sure you actually get the marker on all sides, and you want to make sure all of your markers are actually green. The markers that are important to us are the markers on the side of the cube. Just have to make sure you actually cover all of the orientations, from a good distance where you see all of the markers. Like all of them need to be green at one point in time at least. On the side of the panel, we have 3 dots, as you can see. On this other side, we have, again, we have these 3 dots are on the side of the cube. You don't really see the cube right now, but in the lab, you will definitely have a good understanding of it. So we have scanned all of our markers. It looks like that we have everything we need, and we hit this button, and then we can click finish right here. Okay, we have the global markers. Next step would be to create an actual scan. None of these options need to be changed. Of course, we are going to start the scan, and I want to see a preview of my scan. You have to move this again at an optimal distance as much as possible. Of course, we have to click the start button. So you see these yellow areas are being scanned, and when the areas turn to blue, it means that this surface is completely scanned. So you want to start with yellow. You want to move this around as much as possible. You should not move this very quickly. You have to take your time. And then you are going to build your scanned cube. One thing you want to make sure to check when you're done with the scanning, of course, one thing you want to make sure to check is any holes that you might have on your cube specifically, which is that usually will be covered if you do multiple runs on your scan. So to me, it looks like we actually have everything ready. Everything is actually complete. I'm going to start the play button. I'm going to click the play button on my 3D scanner, and we have the scan. I'm just going to click finish. Okay, so we have the scan. We can zoom in. If you zoom in, you look at the sides. There shouldn't be any holes in your scan. And we have everything we need. Okay, so the only thing that remains right now is to remove the extra parts. Right? I'm going to use the lasso select tool to select the parts that I want to delete. Okay, so we want to remove these extra parts, which means that we can hold the shift button, and then it will enable selection with the lasso tool. You can also, lasso tool is already pre-selected. I am going to use the lasso tool. It wasn't a clean cut, but we'll try to do it better this time. Then holding the shift button is very important. Otherwise, you won't be able to select Okay, looks like there's a couple of things left. Let's see. Looks like we have gotten everything, and as you can see, we have a cutout of the whole thing here, which means that we actually have to do another scan to add this last part to the model and be done with the whole thing. Okay, so let's do a new scan. We actually have to save this first. Very important part that I forgot to mention. I want to get rid of the markers. One thing you see here is that we have a couple of holes here that these might cause an issue. We'll try to get them with the next scan. We also have a couple of leftovers right here, so I want to get these as well. And then save this. So for the new scan, one thing you definitely need to do is to make sure you're actually scanning the bottom, not the sides, because the markers are oriented differently, and we want to make sure we actually can fuse these later on. So let's just start with the new scan. Again, we're going to do the global markers. Everything needs to be at an optimal distance. I think we have the markers of the black sheet. We just need to take care of the sides. I see the 3 markers on the side here. I see the 3 marker on the side as well. I see the 3 markers on the side as well. And then the last one is going to be the 3 markers on the back, which we have again. Let's do another run to make sure we have all of the markers that we need. Looks like we do have all of the markers that we need. You want to make sure that your panel does not move. My panel just moved, so I have to redo this again. The panel movement is a very important problem. Your panel should not move. Very important part of this. Panel should not and cannot move during your scanning. Okay, should be good to go. We're going to click finish, and then next part is going to be do the scan itself. We want to scan the actual geometry, click scan, and you want to make sure you actually turn on the preview. There we go. You have to move this in all direction to make sure actually every part is covered. The corners need their own attention. Again, learning how to do this is not that difficult. It just needs a lot of patience. I seem to not be able to get rid of these, the 3 points that we have there. They might actually be just, they look to be just an anomaly in the system. So I'm going to stop my scan. And then when you click finish, we are going to have our geometry. I wouldn't call this the best scan. As you can see, there are some leftovers here, but it will do the job fine. So the only thing we really need to do is to get rid of the extra parts. Okay, so hold the shift again. One thing you want to do is to make sure you actually are as level as possible. You can see I have selected some part of my cube here, which will affect the surface area, the final surface area that will change your geometry. So as you can see, this will affect our geometry. Since we are fusing the two devices, this shouldn't really be that much of an effect, but it will have some effect. So you want to try to make sure that this sort of scenarios do not happen. Okay. For some reason, the selection is causing an issue for me. Yeah, it did work eventually. You want to make sure you actually don't get anything from the top of the cube. That's why I'm having this much of difficulty here. Okay, I think we got everything. Looks like we have everything, and we should be done. The only thing we really need to do right now is to fuse these two together, these two scans together. Yeah, so in the process of combining these two, we want to go from feature alignment to marker alignment specifically. And you see all of these markers on the side of the cube. You want to make sure you actually select the correct side. So the nodes should be like this, which means that if I rotate this, I have to find a similar nodes, which I think is this side. If you look at the other sides, they all have different nodes, but this one is the only one that looks similar. So you go from feature alignment to marker alignment to be able to select the markers. The markers that we are interested in are all on the side. So let's actually put this to the side and try to find the same marker. This looks to be the same side. One is top here, one is bottom here, and they look to be the similar side. So I'm going to hold the Alt button and select the one here, select the same one on the other side. Select one here, select the other one on the other side. Select one here, select the other one on the other side. And then click Align. The alignment is done. See, we have a cube, we have built a cube, and we should be able to go back. You have your cube right here, the full cube. Next step would be to export this model. We have the aligned geometry, as you can see. This is a cube on all sides. The next part would be to mesh. We don't really need to change any of these essentially. What happens here is that this change your model to a CAD model, and the number of triangles you use here is going to be important in determining the roughness of your surface. So increased number of triangles will give you a better geometry, but everything else can stay the same. Okay, so we have our new mesh, and we can export our cube. We have to export it as an STL file. Just have to keep that in mind. We have the new STL file. The next step would be to do the 3D printing. Okay, so we have created our CAD file. Next step would be to prepare our CAD file for 3D printing. To do so, we have to use something called slicing software. Okay, so the slicing software that of interest for us is called the Creality slicing software, which is the software that comes with the hardware that we have purchased, which is a Creality 3D printer. Right? I have my file here. It automatically recognizes my file as a Creality file because I don't really have any other CAD software here. So I'm going to double click on my CAD file, step file. It's asking me whether I want to open it with Creality Print. And I hit OK. So the goal here is to slice our CAD model so the 3D printer actually prints one slice at a time. And the slicing of our CAD model is not a very difficult thing to do. It's basically just, especially since we only have a cube, it's just basically a matter of clicking this slice button. But we want to make sure we actually have this in the correct orientation. So as you can see, it is not the CAD file that we have, it is not on the bed. So we have to make sure we actually click this auto orient. And it is now completely flush to the bed. Okay. And right here, it gives me all of the dimensions of my cube. The dimensions are 64.91 by 64.65 by 50.08 millimeters, which this is a scan of a cube that is 50 by 50 by 50 millimeters. So you can see I have basically 10 millimeter error in two of the sides, which is all right. You just have to report this error. And we want to make sure you actually understand that this error exists. Okay, so what we can do right now is to click a slice, and it will do the slicing for us. But before clicking the slice, I want to talk about the options a little bit. So on your right, we have the layer height, which is your base layer height, and each layer that you are slicing, the height of those layers. And we can actually change a lot of different things here. But that setting of interest to us is called the infill density. Essentially what happens is this cube, we are going to print the shell of the cube. Inside of it, we can have a completely solid object, and that's where the infill density is 100%, or we can have a sparsely, populated inside of that shell, right? Right now, by default, my infill density is set to be 15%, which essentially means that inside of this shell, we are going to have 15% 3D printed material. 85% of it will be just empty. And your goal in the lab would be to change this to have 3 different prints. Each group will do 1 print. One group will do 5%, one group will do 10%, and another group will do 15%, or as your lab manual states. But right now, I'm just going to keep it at 5 because if your infill density is smaller, then you are going to have a faster print. Okay. So now we are ready to slice our geometry. We have the slice geometry. As you can see here, let's actually see the side of it. This is our slice geometry. Not the best slicing, I would say, which tells me that we might have some issues at the end of the print. We might actually not get the best print. But again, that is all right for this, for the purposes of this lab. Let me slice it again. Let's actually do a slice all. And then we can export the G code. So the file is not a CAD file anymore. It is called a G code. And the G code, we need these SD cards because our printers run on SD cards. We don't have a direct connection to our laptop. So I'm just going to plug this SD card in. On the other side, I'm just going to come in front of the camera for a second. We already have a couple of different G codes on here for the previous labs. I'm just going to save mine here as well. I'm going to call it test 1. And we are ready to print. Let's just make sure that our file is actually copied on the SD card. Right here, test 1. So I'm going to eject my SD card, and then we are ready for printing. Okay, last part of this lab is the 3D printing. The SD card, you can actually put in from the left side of the 3D printer. You want to make sure your 3D printer is on. And on the display here, this is not a touch screen. You'll have to control this with a knob. We have 4 different options. One is called print, prepare, control, and leveling. For the 3D printers we have in the lab, we don't really need to do any leveling for the most case scenarios. But if your printer doesn't work, you want to make sure your TA is in the loop and can help you with this. So I'm going to select print. Then I'm going to select my own file, test 1. And then confirm. So it will do an auto leveling itself. You see the nozzle that came out. It is going to be heated a little bit. We have enough filaments to make sure we actually can do the print. Right now we are at 1% print scenario. It takes a little bit of time. You just have to bear with it a little bit. And we are going to wait for it to start the print in a second. But this is basically it. This is where we want to be at. You want to make sure you actually record the print time. There is an estimate of the print time right here at the bottom. The reason we are waiting here is because the nozzle and the bed need to heat up. Right now I'm looking at 120 degrees for the nozzle, and we need to reach to 220 degrees Celsius. This is degrees Celsius. And for the bed, we are at 40 degrees Celsius. We need to get to 50 degrees. So again, as soon as the printing is started, it will give you an estimate, which is a pretty accurate estimate of how much time it will take for you to print. You want to make sure you record that time, and as long as you're in the lab, record the use a watch or whatever, or your phones to record the actual print time as much as you can. The process is a lengthy process, but as soon as your print starts and as soon as you make sure that the print is going fine, there is nothing else you need to know. You just have to wait for the print to be done. What I'm going to do is I'm going to give a couple of minutes. We are 6 degrees Celsius away from 220. We are getting there. I just want to make sure that the print starts, and then we'll be done with this part of the lab. This is a lengthy lab. Just have to bear with it. But the things you learn out of this lab are going to be very, very useful. You will learn how the 3D printers work. You will learn how 3D scanners work. And the worksheet part of it is not that difficult to do. So right now, we have reached the temperature. That's why the bed started moving. And then we have started the print. There we go. That is it. Thank you for joining us, and see you all next week.